Welcome to my channel. Today in this session, let us discuss some MCQ in case of control system. The question number 1 is, for the system shown in figure given below, the input waveform to yield a constant error is. What about the constant error which yields for the provided figure? Right? Either it is a step, ramp, parabolic or the impulse. Okay. So let us find what about the constant error here. Okay, they given us nothing but an closed loop transfer function without an unity feedback. We need to convert this into the open loop transfer function. To convert this into the open loop transfer function, we have to rewrite that transfer function equation as g of s by 1 plus g of s h of s minus g of s. So, in the problem, the g of s is the upper term. Here, g of s is equal to 10 into s plus 10 divided by s plus 2, and h of s is nothing but s plus 4. Okay. So, I am once again rewriting this. G of s is equal to 10 into s plus 10 divided by s into s plus 2, and h of s is equal to s plus 4. Okay, and by substituting this, I need to find out the open loop transfer function. Then only I am able to find out what about the constant error here. So the open loop transfer function I obtain as 10 divided by s plus 10 divided by s into s plus 2, the whole divided by 1 plus 10 into s plus 10 divided by s into s plus 2 into s plus 4, the whole minus 10 into s plus 10 divided by s into s plus 2. This is the case, right? Here I obtain the expression as 10 into s plus 10 divided by s into s plus 2, the whole divided by, I have s into, by cross multiplying this, I have s square plus 2s plus 10 into s plus 10 into s plus 4 minus 10s minus 100, the whole divided by, I have the constant term s into s plus 2. Finally, I obtain the expression 10 by s square plus, that is nothing but I obtain as s square 11s square plus 132s plus 300. This is the transfer function I obtain for the particular block diagram, right? And our aim is to find out what about the error here, right? So the obtained transfer function is nothing but it is an type 0 system. How do we find this is the type 0 system? Because in the number of poles lying in the origin is 0, right? So this is the type 0 system. We well know that for the type 0 system, it produces the constant error only for the step input rather than the other two cases. Other two cases in the sense, it is in the case of step, ramp and parabolic. So for the type 0 system, we have a steady state error only for the step input, and the option A is the correct answer for the question number 1. So I repeat, for the system shown in figure given below, the input waveform to yield a constant error is This is the block diagram given. This is nothing but the system without an unity feedback. So, in order to find out the constant error or which type of input it produces, we need to convert this into the open loop transfer function which has an unity feedback. So for conversion, I have taken the formulas as such, and I obtained the transfer function this for the particular transfer function. The transfer function is a type 0 system, and the type 0 system, in the constant error is only in the case of step input, right? And for the question 2, the question 2 is the positional and acceleration error coefficient for the open loop transfer function g of s is equal to k divided by s square into s plus 10 into s plus 100 respectively are. So this is the equation, and we need to find out the positional and acceleration error. Okay, so by saying the question itself, we are able to see that only the acceleration error exists and there is no positional error. Why? Because is for the given g of us, it is an nothing but an type 2 system. Okay, so I am identifying this as the type 2 system as by the means of number of poles at the origin here is 2, right? So the positional and acceleration error coefficient is nothing but it exists in the case of acceleration error. It doesn't exist in the case of positional error. Positional error. Why? Because is we can also able to find out the Kp and Kv values. Kp is equal to limit s tends to 0, g of s, h of s. This is the formula to find out the Kp, right? And if I substitute this limit s tends to 0, k divided by, I have the k divided by s square into s plus 10 into s plus 100. If this is my g of s and consider h of s is unity, so I will substituting s as 0 here. I have k divided by 0. Anything multiplied by 0 is nothing but 0. K divided by 0 which is equal to 0. So for Kp, I have the ESS in there. It is also as the positional error. ESS is equal to 1 by 1 plus Kp, right? Steady state error. So for Kp, for the particular type 2 system, it will be equal to infinite, right? And only the acceleration error exists. That means acceleration error Ka is equal to limit s tends to 0, s square, g of s, h of s. Okay, here I have limit s tends to 0, s square into k divided by s square into s plus 10 into s plus 100. This s square and s square term cancels. By substituting the s value as 0, we have the value as k divided by 1000. Okay, so for the particular case, for the problem number 2, option D is the correct answer. Only the acceleration error exists for the type 2 system and there is no positional error. Okay, so these are the questions already which is asked in the case of GATE. Those who are preparing for the GATE examination and also for the competitive examination, I think it would be helpful for you. If you like this video, like, share and subscribe. Thank you.